In lesson 5.4, we're analyzing graphs of polynomial functions. So you'll need your graphing calculator to make a table of values. So on your graphing calculator, you want to push the button on the top left that says y equals. Then you're going to input this equation under y equals. Make sure you type the negative sign and not the subtraction sign for the first minus. So under y equals, we're going to type negative. And then to type x, there's a button. There's a button in the middle, or closer to the top. There's a button that looks like this. So that's how you type x on your calculator. So negative x, and then this button is for the exponent. And then to get out of the exponent, push the right arrow. And then for the squared exponent, you could type this button, or there's also a squared button. It is close to the 7, just a little bit up and to the left of the 7. Okay, so anyways, you're gonna enter this function in your calculator, and then you're gonna hit second, and then the top right button to get to a table. Okay, so if you hit second table and you don't see a table, hit second window and make sure that under independent and dependent, they are both on auto. So hit second window. You also want to make sure that your delta table, so the change in your table, says 1. Okay, so second window, table start, you could start it at 0. Delta table 1. Independent and dependent on auto. Okay, hit second graph. And, well, you don't need a table to know that if you plug in 0, you get -3. And let's scroll up to get the other points. And now scroll down in your table. Okay, so now we've made a table. Now we're going to graph the equation, at least the points that fit. -1, 1. 0, -3. 1, -1. 2, 1. 3, -3. And we know that it's going to shoot up on the left based on our table, and it's going to shoot down on the right. And this makes sense because look at the degree. The degree is odd, so that means one side goes up and one side goes down. The leading coefficient is negative, so that means the right side goes down. The leading coefficient always tells you what the right side does. All right, next they want us to determine the consecutive values between which each real zero is located. So there's a real zero somewhere over here, and over here. So for part B, we know there's a real zero between -1 and 0. We know there is one between 1 and 2. And we know there's one between 2 and 3. And you could also see that by looking at the table. It goes from positive to negative. The y can't go positive to negative without crossing 0. It goes negative to positive here, and it goes positive to negative here. So if the function is continuous, it cannot go positive to negative or negative to positive without crossing 0. All right, next thing they want is the an estimate of the x-coordinates of relative maxima and relative minima. All right, so looking at the graph, it seems to have a relative minimum here and a relative maximum there. We know there's no true maximum because the left side goes up forever. There's no true minimum because the right side goes down forever. But we have a relative min and a relative max. Okay, so for the point around 0, -3, that's a relative min. So I'm going to say we have a relative min. And that is at x, and it's around, so I'm going to put the squiggly lines to show it's not exact. Relative min around x equals 0. Then we have a relative max, and it seems like that is around 2. Okay, let's do number 2 using our calculator again to make the table. So you might want to pause the video now to put the numbers in your table, or to put the equation in your table, I should say. So scrolling up and down in my table, I can see that from -3 to +2, that's when our y values are the closest to 0. So I'm going to use that range. Now I'm going to plug in the f of x or y values. All right, the degree is even, so we know that both ends are up or both ends are down, but the leading coefficient is positive, so we know both ends are going to be up. Okay, first point doesn't fit on our graph. -2, -4 is down here. -1, 0.75 is over here. Okay, so you have to be careful with where you draw the arrows. We know that it's going to shoot up on the left side based on the point we couldn't graph. It's also going to shoot up on the right side. So even though these points don't fit on the graph, you do need them because they tell you that it's going to go up on the end of the graph. All right, so now we have to say where the zeros are. So without even looking at the graph, I could find this by looking at the table. If the y value goes positive to negative, there has to be a 0 in between those x values. So between -3 and -2, there's a 0. And then it goes from negative back to positive. So it has to cross 0 again. And remember, you're reporting the x values. So between -2 and -1. All right, now we have to estimate where the relative, or either the max and the min or the relative max and min. So there is no maximum because both arrows go up. We do have a relative minimum down here. Actually, that's an absolute minimum because it never goes lower than that. So we have a minimum around, that would be around -2. And then we don't have a maximum, but we have a relative maximum. So a temporary maximum. And that would be at x is 0. And there is no absolute maximum because both ends go up. For numbers 3 and 4, we have to sketch a polynomial function following the characteristics they give. Okay, so for number 3, they say it's even. As soon as you see that it's even, you know that either both ends have to go up or both ends have to go down. Whenever it's even, Both ends go the same direction. We also know there's a 0 at -2. There's one at +1, one at +3, and one at +5. So now you just have to draw a graph that has the same end behavior on the left and right and goes through those 4 points. And you also could have drawn it with both ends going down. Okay, for number 4, we know it's a 5 degree. So because it's 5 degree, we know that one end goes up and one end goes down. We know there are zeros at -4, -1, +3, and there's also a relative max at -2. So I'm going to go to x equals -2, and then I'm going to go up. All right, so I know this has to be a peak. So I'm going to start at that peak, and then I'm going to make sure that, well, if my left side is down, I need to make sure my right side is up because it's an odd degree. All right, now the problem, if I keep going up, it's going to look like a 3rd degree function. So I'm going to make one more downturn and then go up. The degree -1 is the most possible turns it can have. So if this is a 5 degree, the most times it could turn is 4. That doesn't mean it has to turn 4 times. It's just the maximum possible number of turns is 4. Okay, for number 5, go ahead and put that in your calculator under y equals. Okay, when you're done putting that in your calculator, and if you hit graph on the top right, you should see the graph. If you hit graph and you don't see the graph, hit window on the top row. And usually for window, I like to put in -10 for the minimum for x, 10 for the maximum, 1 for the scale, and then repeat it for the y's. So for y minimum, I usually default to -10, then +10 for the max, and then 1. However, if you do this, you can't see the top of the graph. And the reason you can't see the top of the graph, if we plug in 0, we see that the y-intercept is 16. So then I'm going to go back to the window and change the y max to 16. So if you can't see the graph, you need to play with the window. And if you're not sure where to put the window, look at your table. Your table will tell you what x's and what y's you might want to look at. Okay, so for part A, they want us to find the zeros. So zeros are x values that make y equal 0. So if you go to your graph, you can see there are 2 x-intercepts. All right, next to the button that says graph, there's a trace button. If you use the trace button, you can use the left arrow and the right arrow to try to get y close to 0. So usually the trace button won't take you exactly where you want to go because it always jumps a few decimals. But if you use the trace button, you could see that the zeros are around -2 and +2. So whenever you get around the x of -2 and the x of 2, the y gets really close to 0. All right, next we want the y-intercept, actually the x and the y-intercepts. So this seems kind of redundant. The zeros and the x-intercepts are the same thing by definition, so those are going to be the same. The y-intercept, you can just tell by looking at the equation. If we plug in 0 for x, we would get 16. And then the turning points. So if you look at the graph, I'm going to make a rough sketch. So the graph looks something like this. There are turning points here, here, and here. So we need the x coordinates where that happens. And so using the trace button, you could see that these happen around -2, 0, and +2. And those are x coordinates. Okay, the axis of symmetry. The axis of symmetry for this. Usually polynomial functions are not symmetrical, but this one is. The axis of symmetry is x equals 0. If you draw a line straight down at x equals 0, you'll see that it cuts the graph in half. For part C, we have to figure out when the graph is increasing, decreasing, or constant. So if you look at the graph, this part of the graph is going down, so it is decreasing. So I'm going to say it is decreasing when x is less than -2. It is also decreasing right here. So it's also decreasing when x is between 0 and 2. All right, and when it's not when it's not decreasing, it is increasing. So it is increasing when x is between -2 and 0. It is also increasing when x is greater than 2. And it is never constant. Constant means it's horizontal, and this graph is never horizontal. All right. Okay, put number 6 in your calculator. I'm going to make a rough sketch. So if you graph number 6, it looks something like that. So if you use the trace button, it has zeros around -1 and 0. These are the x coordinates where the y is 0. X-intercepts are the same thing, so it has x-intercepts at -1 and 0. The y-intercept, if we plug in 0 for x, we get that the y-intercept is also 0. And now we have to find the turning point. So looking at the graph, there's one turning point up here. That's where the graph goes from, it was going up. Imagine you're on a roller coaster. So if you were on this ride, it was going up on this part of the ride, and then after that it's going down. So it has one turning point. And we found that that was around -0.64 using the trace button. So if you use the trace button, you want to keep hitting trace until the y goes down. So you want to trace on the left side and then go to the right. And for my calculator, as soon as you get to -0.64 and then you continue, the y value starts to decrease. All right, so now we just have to say, well, part B is the axis of symmetry, but it doesn't have an axis of symmetry because it's not symmetrical. And then for part C, we have to say where it's increasing and decreasing. So it is increasing when x is less than -0.64. And then after that point, it is decreasing when x is greater than -0.64. Okay, for the last few problems, they give us a graph and there are a few things they want us to answer. Okay, first assume that there's arrows on the end of number 7. All right, first thing they want is the x-coordinate of every turning point. So whenever it goes from increasing to decreasing, that is a turning point. So the first one is at around So I would say that's around negative 2.7. And then they also want us to say whether it's a max or a min. That is a relative max, so in parentheses, I'm just going to write max. All right, there's another turning point here. I would say that's around negative 1.7. Remember, you're reporting the x-coordinate, and that is a minimum. Okay, next turning point is here, maybe around negative 0.6. And that is a max. Next one is at positive 0.6. That's a minimum. We have two more. There's a turning point around 1.7. That's a maximum. And our final turning point is down here. Looks like it's around 2.7, and that's a minimum. All right, now we have to estimate the x-coordinate of each zero. So it looks like those all fall at integer coordinates. -3, -2, -1, 0, 1, 2, and 3. Okay, the smallest possible degree. So what you do is you count the turns. They're circled in red. We had 6 turns, so we add 1 to that. The smallest possible degree is 7. There are 6 turns, you add 1. So remember, degree minus 1 equals the maximum number of turns. Okay, part D, the domain and range. So we have an odd function. We know it's odd because one end goes up and the other end goes down. Whenever it's odd, the domain and the range are all real numbers. So the domain and the range are all real numbers. When it's even, the domain's all real numbers, but the range is not. All right, so let's do number 8. First thing they want is the turning points. So this one doesn't have as many. We see a turning point here, one here, and one here. So there's a turning point at -2. That is a max. There's a turning point at -1. That is a min. And there's a turning point at around 0.4. That is also a max. All right, next thing they want is the zeros. So we have, looks like 2 of those. I see a 0 here and a 0 here. So estimating where those occur, I would say around -2.2 and -1.8. Okay, and then part C, smallest possible degree. Part D, domain and range. Okay, so the smallest possible degree, we count the turns and we add 1. Smallest possible degree is 4. The domain's all real numbers. Okay, the range is not all real numbers. So notice the arrows go down forever, but they do not go up forever. So we have to figure out what's the highest point. The highest point, and remember, high and low, you look at the y. So the highest point looks like it's at 2. So I'm going to say y is less than or equal to 2 because the y values always stay below 2. Okay, that is it for 5.4.